Okay, right. So in the previous classes, we defined, first we have seen the definition for the machine design. After that, we discussed about classification of machine design. Then we discussed about what are the various phases of a design process. Now in today's class, we'll see what are various factors. Somebody is switched on the mic. So you switch off your mic.
Switch off your mic అంటున్నాడు. నీకెందరూ వెళ్ళిపోక నేను బలమే పెట్టా.
అరే ఎవడాడు బూతులు మాట్లాడుతాను నేను చేస్తా ముందు సెన్స్ నేర్చుకో. మైక్ ఆఫ్లో ఆన్లో ఉందా ఆఫ్ చేయాలంటే బూతులు మాట్లాడుతావేంటి? మైక్ ఆన్లో ఉంది కూడా అర్థం కాలేదు నీకు? ఆ మాత్రం ఆన్లైన్ ఉంది అట్నే బూతులు మాట్లాడుతున్నావు అందరికి. ఓకే రైట్. So today we'll see what are various factors to be considered while designing a machine or a machine component. So the design engineer has to consider certain factors while designing any machine element or a machine. So in that, the first one is what type of device it is or what type of mechanism can be used in the given machine. So that means we know mechanism is nothing but an arrangement of different elements of a system. We'll call it as a mechanism so that it can produce the required motion. So if you arrange all the elements in a systematic manner, so it will produce the required motion. Maybe it may be rectilinear motion or curvilinear motion or whatever it may be, whatever may be the type of motion. Again, in curvilinear motion, you have a simple harmonic motion or periodic motion like that. So maybe what is the intended function of that mechanism? So he has to arrange those things, all the elements of the machine in such way that the required motion is generated at the output, as an output. So for that, he has to make sure that whether he is what is his requirement, whether his requirement is fulfilling the given mechanism or not. So and at the same time, while designing the mechanism, he has to make sure that it should be simple and as well as effective. So then only it is the best design. So a designer has to make sure make sure that he has to use a proper mechanism. That means he need to consider the kinematics of the system. Then based on those kinematic principles, he need to design the mechanism required for the given machine element or machine number. Then next category is, next factor to be considered is a material. So always this is also, material is the one of the most important parameter or factor to be considered by the designer while designing any machine element or machine component. So in the material, what he has to look at it is, first he has to look at what are the various properties of this material, especially what is the strength of the material, what is the stiffness of the material, and what are the other properties like what is the corrosion resistance, is that material is having corrosion resistance or wear resistance, or maybe some other, what is its heat transfer coefficient, like that. All those material properties, depending upon the application, the designer has to take care of all these things. So not only that, so whenever he is designing for a failure or he is designing against certain kind of loads, then he has to make sure that whether that material is able to withstand that kind of load or not. He has to take care of that also. That means that is also one of the factor he needs to be considered. So, and also not only that, one more point here is whether the material is going to fail in which manner, whether it is going to fail in a ductile manner or whether it is going to fail in a brittle manner. So that is also going to be one of the important factor while selecting a material for a machine component or machine element. Then next one is what are the various types of forces acting on the elements. Machine elements in the sense machine elements. So it need not be only the forces. We can say we can generalize it. There are loads. Instead of forces, I can say it is here a load. What are various loads on the machine elements? So that means there may be different kinds of loads acting on the machine elements, whether it may be a direct tensile stress, a tensile load or a compressive load, or it may be a bending moment, or it may be a twisting moment, or maybe there may be a direct shear stress, shear load is also may acting on the given machine element. So based on that, he has to consider all the loading happening to that machine element, and based on that he has to calculate the dimensions, that is the size of the machine element, so that it is going to withstand the given applied loads without failure. So therefore the design engineer has to consider what are the various forces are going to develop or going to operate on the given machine element when it is put into the operation. So therefore this is also one of the impacting factor a design engineer need to consider while designing a machine element. Then next, so size, shape and space requirements. So like I think I already told in the previous class, so designer cannot design as per his own imagination. So there should be some constraints. If we design some component with some size that may not be available in the market as a standard in a standard form, or sometimes it may not be possible to produce that size also. So while designing this, he has to make sure that whatever sizes he come across, so that size should be feasible one. So that feasible in the sense, you cannot simply say this much size and that much size, which is not suitable for the manufacturing conditions. So you cannot say something like that. So therefore, he has to take care of the size while designing that, or while evaluating the size of the component. He has to look into these things also, whether this size is practically feasible or not. He has to consider those points also. Simply by taking the mathematical equations and solving it. Okay, I have taken the torque equation, I use the torque equation, I solve it. From the torque equation I got this is the diameter. Okay, you need to produce this diameter shaft. So just like that, the design engineer don't say like that. So he has to make sure that whether that size, whatever size he got from the calculations, practically is it feasible or not. He has to verify that also. So therefore that is also one more important factor, size. Similarly, shape also sometimes. So depending upon the shape, suppose so for the same cross section, so let us say if I take an example of the shaft again, the shaft may be produced in different shapes. So I can have a circular cylindrical shaft, means having circular cross section. I can have a shaft having a rectangular cross section or square cross section, or maybe for that matter some other cross section also. But only thing is, he has to evaluate what are the merits of different shapes here, then only he has to finalize it. So if I take instead of circular shape, if I take a square or rectangle, so generally when compared to the circle, square and rectangles have a vertex points, which are going to be the more stress prone areas in machine elements because of stress concentration. So therefore the design engineer has to look into this aspect also, that is the shape of the component also. So in addition to the shape and size, then he has to make sure that whether his design is following or fulfilling the space requirements or not. So that is also one more factor the designer has to consider while designing its component. Then next one is the method of manufacturing of each component and their assembly. So like I mentioned here, so once you arrive at the sizes and shape and the space requirement, based on the space requirements, then you need to specify for each and every part of the machine or mechanism, so how to produce that each and every part. So that can be done through this by specifying the manufacturing processes for each component. And also he has to consider how we can assemble all those elements also, like what type of joint you are going to use in the assembly, or maybe whether it is a permanent joint or a temporary joint. So based on that also he has to decide all other the element components. So therefore the manufacturing methods and also assembly of the each and every component is also going to be the important factor to be considered while designing a machine element. Then next comes how it operates. So that means, so he has to provide the instructions how to operate the machine or a mechanism. So is he after producing the machine, is he after producing the drawing or design, is he in a position to explain how it is going to operate? So then he has to give those instruction manual so to the operators. Not only that, suppose if if the machine is requires lubrication, whenever there is a sliding parts are there in your machine elements, so then whenever there is a sliding pair is there, obviously there is a friction is there. So now due to friction there is some energy loss from the machine. So to overcome that energy losses or to improve the efficiency, then is there any kind of lubrication is required to operate this machine. So those things also need to be specified or need to be considered before designing the machine. So therefore, that is also one of the important factor need to be considered while designing a machine components. Next comes reliability and safety aspects. So again, reliability is, so you are designing a machine component. So what is the reliability of that component? Means out of 10 instances, how many number of instances it is going to work as per the specifications. That is what we call it as a reliability. If out of 10 instances, the component is perform its function as intended 10 times, then we can say it is 100% reliable. But because of some other uncontrollable factors, no component is going to be 100% reliability. So there may be at least all the components should have at least 80 to 90% reliability. So then, since we are saying that here the reliability is not complete 100%, so there may be a chance of failure of some of the components. Then, if such kind of failure is happened, so then what should be the safety aspects need to be considered to prevent any accidents or any hazardous environment surrounding the machine elements. So therefore, the designer has to consider the safety aspects also while designing the machine component. Then inspectability. So that means how we can check whether before operating your machine or machine component or machine element, is there any possibility of checking the instrument whether it is perfectly all right in all aspects or not. So the designer has to provide such kind of mechanism also. So because in order to avoid any unwanted or unwanted accidents, so there should be some mechanism to inspect the machine before operating it. So is the designer engineer able to provide that? So after producing the component, so therefore he has to make sure that he has to consider this point also while designing the component itself. Then the final one is the maintenance, cost and aesthetics of the design product. So these are also very important. So he has to look into what are the future requirements for the maintenance, also what is the maintenance cost as well as what is the cost of the component itself, and also after the final designing, how it look like, whether it is pleasant to the customer. So then only there will be survival for the design. Otherwise, even though it is technically sound, your design is technically sound, but for looks it is looking ugly, so nobody is going to take the design. So therefore, aesthetic sense of design is also one of the important parameter or factor to be considered while designing any machine component. So therefore, these are various factors a design engineer need to be considered while designing a machine component. Okay, so right. So next we will move to the next topic, which is standards and standardization. So what is standard? Why we require standard? What is the standardization? See, like I given an example earlier in previous or day before yesterday class. Say there are some standards are there, of course. Okay, so before going to that, here we first will see what is a standardization. A standardization is nothing but a set of specifications defined by a certain body or an organization to which various characteristics of a component or a system or a product should conform. So that means, so whatever may be the whether it may be a component or it may be a system or it may be a product, whether that component is governed by a certain characteristics or whatever may be the characteristics of those components, whether they are governed by a given set of specifications or not. So if they follow that, so then we can say that the component is a standard component. Otherwise, we won't say that it is not a standard component. So these set of specifications is given by different organizations. So like let us say there is some organization which is called ISO. So ISO is for a quality, an organization which will see the quality assurance for all the organizations. So if you want to see in education system, people will check whether this educational institute is following the quality principles. As for that, there are some norms. So as per those norms, whether these people are following those norms or not. If they are following, they will give some certification. They will say that this college is following so and so standards. So ISO 9001 or ISO 9000, some number ISO 9020 or something like that. Some number they will give. So that saying that, so this system is following certain standards. That means once if it is following certain standards, so then people will easily understand that this system is going to be a standard component based on the standards they are following. So therefore, that means if it is follows the standardization, it has a better efficiency when compared to a non-standardized or non-standard component. So therefore, the standardization is also going to be very, very important. And also not only that, one more important point here is, okay, so the standards, here the characteristics, here in the definition I written here, various characteristics of a component. The characteristics are generally, they are dimensions, shapes, tolerances and surface finishes. So if the system, if the design follows the certain standards in these aspects, that is dimensions, shapes, tolerances, surface finish, not only these, apart from that the other parameters also there, but these are the major things. So then you can say that the component is going to be comes under some standard. So again, like I said, there are different standards are there. The standards are there may be a company standard. So these are set by a individual company or maybe a group of companies. So then you may have another set of standards which are called national standards. These standards are defined by the national ethics body. So that means there is some ethics body will be there. Then they will formulate the governing rules for these standards. So then if they follow, if the given company or maybe industry follow those rules, they will give their standard marks. So examples for this national standards is BIS and AWS. BIS is British Organization for Industrial Standards, BIS. So it is organized by UK. So like that, AWS, ISO, and also some more standards are also there. So those standards are followed by nationally, or they are followed by company to company, or they may follow universally. So like that, based on that, the standards also will vary from 1 to 1. So the universal standards, like I said here, universal standards are nothing but the international standards. These are the standards defined or set by international ethics body and are normally followed by the throughout the world. That is, throughout the universe they will follow. Examples are ISO. So International Standard Organization for Standards. ISO stands for International Organization for Standards. So they will specify the set of governing rules. So in order to fulfill the component is following these international standards or not, ISO standards or not. So similarly IBWM, like that, there are some more international standards are also there. So once they follow, once they govern, once they fulfill the governing rules of these standards, so they will give some certification like, so this component or this company is following so and so standard. So that means people looking at that symbol itself, they can say that they can easily understand whether it is a worthy product or not, whether it is having better features or not. So based on that, the standards can be, in this how standards can be used. Not only in that way, there is another advantage of following standardization. So what are the okay, here given the advantages of the standardization. So the first advantage is reducing the duplication of effort or overlap and combining the resources. So that means here, if you standardize any given part, so then you can reduce the duplication effect, duplication of production or duplication of the effort, and also similarly overlapping. So the duplication is nothing but some kind of overlapping only, and you can combining the resources also can be eliminated if you use standards in the organization. Then bridging of the technology gaps and transfer of the technology. So that means, so if you set a set of governing rules in order to fulfill a certain standards, so therefore that means they are saying that this is the technology you want to have in order to qualify your component as a standard one. So therefore, whatever may be the technology gap between the organization which sets the standards to the industry where the components are producing. So to fill that gap, these standards are going to be used, or that may be the one of the advantages for this standardization. So then reducing the conflict of the regulations. That means if I set some certain standards, like I say, suppose there are some regulations, there are some standards for let us say four-wheelers or cars. So people set by some organization, let us say the government, Indian government is set some standards for the vehicles. So you have to produce a vehicle under BS4 regulations. So that means your pollution controls, whatever may be the pollution emitted by your car should be within this limit. Like that, they will set some standards. BS4 standards means not only this, there are some other standards also there. So standards regarding to the design, size, and also speed controls, and also safety. Like that, so many things are there. The standards for each and every aspect of the design. Then, if the people is following the certain standard, means then there won't be any conflict of the regulation. That means they have to follow those regulations. Then only you will get the certification of that standard. Otherwise, you won't get it. So therefore, these standards can reduce the conflict of the regulations. Then facilitating the commerce. So that means you can easily, if you follow the standards, you can easily sell your product in the market. So that means it will easily facilitate the commerce. Commerce is nothing but selling a component in the market. So without we already know, everybody will knows about it. So if a certain component is there, which is having some certain standards, it can easily sold in the market. It can be easily sold in the market. Otherwise, a non-standard component is very difficult to sold in the market. So therefore, if you follow the standardization, it will facilitate easy commerce. And also, the last one is stabilizing existing the markets and allowing the development of the new markets. So these standards can useful in stabilizing the existing markets as well as development of the new markets. So that means in an existing market you can stabilize it, and also you can provide or you can create a new market for your component, provided if you follow the standards. Okay. So then protecting from the litigation. That means suppose if you follow certain standards, then you don't have any legal issue with your component. You can produce and you can sell anywhere else. So because since you are following the standards, so if I follow international standard, I can sell my component anywhere. So I don't have any legal litigation because I am following the universal standardization, the universal or international standards I am following it. So I can sell my component anywhere. So I don't have any legal problem for that. Or else, if you are not following the standards, you cannot sell your component anyway. So therefore, that is one of the problem without the standardization. So therefore, if you follow the standardization, you may get advantages from to avoid these litigations or legal actions. Okay, so this is how you can. These are the advantages. These are the advantages for standardization. If you put a component into standardization, not only that, suppose if the standardization are there while designing any designer, so first he has to keep these standard sizes into his mind, then only he has to design it. So in the previous slides, we talked about what are the various factors the designer has to be considered while designing a machine component. So then there we have a point about shape, size. So that shape and size, the size is there. So if I follow that, so the designer has to take the standard sizes and then he has to design his component for the standard size only. So he cannot design for any other size. So therefore, so the standardization also will facilitate that kind of flexibility to the designer. So first he has to see into whether the standard is available or not, standard size is available or not, then he will decide his design. Okay, so of course this, I think the standardization and standards are not there in our syllabus, but it is relevant to the next topic, that's why I included it here. So next topic is preferred numbers. So what are preferred numbers? Why will you use preferred numbers in the design? So the preferred numbers are nothing but a series of numbers, and these are first introduced by the French Brouillonist Charles Renaud. So how he introduced this is, these preferred numbers is nothing but a series of numbers arranged in a geometrical progression. So his preferred number is nothing but a system is based on use of geometric progression to develop a set of numbers. Preferred numbers are numbers which can be generated based on use of geometric progression to develop a set of numbers. So those set of numbers people will take it as a standard number or standard size. So that is the advantage of this preferred number. Well, that's why the name itself, it is called preferred number. So whenever a design engineer designs a component, he has to take that size from this preferred number list, so that always everywhere people will follow the same thing, same number. So then it will become a standard. So therefore these preferred numbers are some sort of standards in specifying the size of the component. So in these preferred numbers, again there are two types of series. One is called basic series, the other one is called derived series. So in basic series, again there are five series are there. They denoted or maybe designated, we can call it as designated R5, R10, R20, R40, R80. So these are the five basic series we can say. So using in these five series, how we can generate this set of numbers. So like I already mentioned here, it is nothing but a preferred numbers or nothing but a set of numbers. So how we can specify, how we can generate a set of numbers by this five series. So here we'll see that. So the series is okay. So this is the procedure how we can generate the set of numbers in the every series. The series is established by taking the first number and multiplying by the first number by a series factor. That means each basic series will have some series factor. R5 will have one series factor, R10 will have one series factor, R20 will have one series factor, R40 will have another series factor, R80 will have another series factor. So then, if I want to develop a set of numbers under R5 series, then what I have to do is, I have to take the series factor for R5, and then I need to multiply the first number by the series factor. I'll get the first number in the set. Then the second number in the set is designed by the identified just by multiplying the first number by the series factor, we get the second number. Then third number is second number multiplied by the series factor, we will get the third number. Third number multiplied by the series factor, we will get the fourth number, and so on. You can get a set of numbers like that. So by going on multiplying the previous number by the series factor, you will get the preceding number in the series. So that's what I written here in these slides. The second number is again multiplied by a series factor to get the third number, and the procedure is continued until the complete series build up. So likewise, you can construct the all the series R5, R10, R20, R40, R80. So but to construct the series, what you require is you require a first number and you require a series factor. So how we can get the series factor? So for R5 and R10 it is easy. This Reynolds is defined that series factor for each of these 5 basic series, and they are given by these relations. Your R5 series factor is nothing but fifth root of 10. So these are the series factors for the 5 basic series. So R5 series number is nothing but fifth root of 10, which is nothing but 1.58. 1.58 is the series number, basic series factor, sorry, not series number, series factor for R5 series. Similarly for R10 series, the series factor is 10th root of root 10, which comes out as 1.26. Maybe you will get a fraction number, it is rounded off here, so you will get 1.26. You have to take the series factor as rounded number, only up to 2 digits you need to consider. Beyond that, you don't consider the series factors. So similarly for R20, the series factor is root 20 square root 10, which comes out as 1.12, and R40 series, the series factor is root 40 root 10, 40 root 10, which comes out as 1.06, and R80 is 80th root of 10, which is 1.03. So if you are able to remember, you can remember all these numbers, or else it is easy to remember. Instead of remembering this number, what we'll do is, so we'll take R5 means you have to take 5th root, R10 means you have to take 10th root, R20 means you have to take 20th root, R40 means you have to take 40th root, R80 means you have to take 80th root. So here is whatever number is there in the series, that comes here 5, 10, 20, 40, 80. Of course, here you have to apply the root for 10 only. For each series also, the number will be 10 only. So then use your calculator, you can calculate this, you will get the series factor. So now once I have a series factor, I can construct the set of numbers in any series. That is, suppose if I want to construct R5 series, what I have to do is, first number I will take. So what is the first number we need to consider for any series, or what is the starting number for any series? Okay, so can I take 0 as my starting number for any series? Anybody respond? Roll number 51. Are you there? ఉన్నావమ్మా లైన్లోనే? ఫోన్ ఆన్ చేసి ఎక్కడికి వెళ్ళాడా? 351. No response. So simply switching on and sleeping, right? $351. I'm calling again.
Yes, sir.
ఎక్కడ ఉన్నావురా?
సార్ ఉన్నాను సార్.
ఎక్కడ ఉన్నావు?
ఇంట్లోనే ఉన్నాను సార్.
ఇంట్లో ఉన్నావు కానీ ఫోన్ చూడలేదా?
చూస్తున్నాను సార్, మైక్ ఆన్.
మైక్ ఆన్ అవ్వట్లేదా? సరే, ఓకే. See, I want to create a series of numbers using any one of these series, R5, R10, R20, R40 or R80. So first I have to choose the starting number. So tell me what is the first number you can choose it. So the question is to 351 first. You answer it, then we will move on to the another person. Okay, so Surya said no. Why? Surya, ఆడ 51 మళ్ళా ఆడ ఫోన్ అక్కడ పెట్టి మళ్ళీ అక్కడ వెళ్ళిపోయినట్టుండు.
సార్ ఎప్పుడైనా
If you select 0 as your starting number to multiply the series factor, then what you are going to get?
జీరోనా సార్?
You will get only 0. You are not able to generate any number there. So you will get only 0. So therefore you cannot take 0 as a starting number for our series starting number. So then what is the next number I can consider?
1 సార్.
1. So therefore what we will do is we will take 1 as the starting number for the any series number. So to generate any series we will take the starting number as 1, but that is not the first number. That may not be the first number in the series. So then 1 multiplied by the series factor. So if I take R5 series now, so what I have to do is I have to take 1 and I need to multiply 1 by 1.58, then I will get the first number. See now here in this picture I have shown the all the numbers, all the preferred set of preferred numbers in the R5, R10, R20 and R40 series. So here you can see here 1 is the starting number, then 1 multiplied by the 1.58, it comes out as 1.58 only, but it is rounded to 1.6. So then 1.58 multiplied by 1.58, you will get something 2 point something you will get, again that is also rounded up to 2.5, but don't take 1.6 and multiply this 1.6 into 1.5 then round it off. Don't do like that. So what we have to do is, here this is 1, this is 1.58. Here you have to take 1.58 square. Here 1.58 cube, third number. Here 1.58 to the power 4. Here 1.58 to the power 5. So then you will get the number. Then you round it up to the nearest number. So likewise you will get all these sets of numbers. So okay, so we'll do it here manually also. We'll do and we'll check it. So why it is named as R5? See in this series how many numbers are there? Only 5. 1, 2, 3, 4, 5. That's why it is R5. R5 series. Okay, remove disregard 1. So 1 is the starting number for anything. So but the remaining is the series. In the series the numbers are only 5. That's why it is called R5 series. So now let us just check for one series, then we'll remaining I will leave it to you. So I'll take a calculator and I'll show it to you how we can derive the numbers in the series. Okay, so now I think my screen is visible, right? Is the calculator is visible to you?
Sir.
Right. So first number anyway 1.58, there is no issue with that. So 1 multiplied by 1.58, you will get only 1.58. Since it is close to 1.6, I round it up to 1.6. Then I'll take square of this. So what I'm getting, if I take a square of this, how much I got? 2.4964. So that means I can round it up to 2.5. But instead of taking 1.58 square, suppose if I take 1.6 multiplied by 1.58, then how much I am getting? 2.52. It is higher than this 2.5. So I cannot construct the second number, third number like this. So always you have to use the square series factor only. So therefore you got it as 2.5 here. Then next number, to get the next number. So what I need to do is 1.58 to the power 3. I need to take to the power 3. So how much I got it as 3.94. Then it is rounded up to 4 here. You can see here you got it as 4. Then next number 1.58 to the power 4. Fourth number is going to be to the power 4. So I got it as 6.23, which may be rounded up to 6.3. Then the final one is 1.58 to the power 5. To the power 5. So I got it as 9.84. It is rounded up to a standard number 10. So like this, you can construct the series number. Similarly, if you want to construct the R10, first the series factor for R10 it is 10th root of 10. So what is the 10th root of 10?
1.2.
1.21. We already see.
1.26.
1.26.
26.
It is 1.26. So now the starting number is 1. Starting number is 1. Then 1.25. You need to multiply this one by 1.26. So you get 1.26. It is rounded up to 1.25. So then you got 1.6, 2, 2.5, 3.15, 4, 5, 4.6, 8, and then 10. So now see, if you compare these two series, R5 and R10, whatever numbers are there in R5 series, your R10 series will also have those numbers. You can check that also. So here, in addition to the 5 numbers what are available in R5 series, you have 5 more numbers in R10 series. See, 1 is there, 1.6 is also there, 1.6, 2.5, 2.5, 4, 4, 6.3, 6.3, 10, 10 is there. In addition to that, so in R5 series, in 1 to 10, you have 5 numbers. In R10 series, between 1 and 10, you have 10 numbers. So likewise, in R20, you have between 1 and 10, how many numbers you will have? 20 numbers will be there. Similarly, for R40 series, you have 40 numbers between 1 and 10. So that's why there is a geometric progression in all this number. So that's why you are getting these many numbers. For R5 series, you are getting only 5 numbers. For R10, you get 10. For R20, you will get 20. For R40, you will get 40. R80, you will get 80 numbers. Okay, these are only, see, if you see whether it is R5, R10, R20, R40. So R, for that matter, if you take R80 also, your series numbers will have only the lower limit is 1 and the upper limit is 10 for all the series, whether it is R5, R10, R20, R40, the series starting number should be 1 and ending number should be only 10. So all basic series will consist of the highest number or maximum number is only 10 and lowest number is 1. In between, for R5 you have 5 numbers, R10 you have 10 numbers, R20 you have 20 numbers, R40 you have 40 numbers. Okay, so likewise you can construct you can construct the basic series. These are the basic series. Now suppose I want to select a size which is beyond 10, then what I have to do? So these basic series will provide the size, maximum size is only 10, but I want to design a component whose size is more than 10, then what I have to do? So that is not available in these preferred numbers. So then what I have to do is I need to go for derived series. So that is here the next one is a derived series. So the name itself suggests that it is these series are derived from the basic series. So name itself suggests derived means it is taken from somebody. So that is nothing but basic series. These derived series numbers are generated from the basic series numbers only. So again in derived series there are 2 types of series. One is increasing numbers, another one is reducing numbers. Series with reducing number of particular basic series, that is one kind. Then other kind is series with increasing the number of particular series. These are the first one is you are reducing the number of reducing the set of numbers in the given basic series. We'll call it as reducing series. That is again a derived series. Similarly, sometimes you can increase the numbers of a basic series. We can call it as another kind of derived series. So how we are saying that it is a reducing number. So let us say if here I have something, I specified something like this, R 10 by 3. So what are the numbers in this series? It is a derived series from R10. So this R10 indicates this is the basic size. So by the 3, this designation is nothing but it is a derived series. When the meaning of this R10 by 3 is nothing but in the R10 series, I need to take every third alternative number from the basic series. So that means here, if I take R10, so first one is 1. Okay. So this I have to select. Then third one, 1, 2, 3. I'll omit these two. Then I'll consider this. Then 1, 2. I'll omit this and this. I'll consider this. Then I need to omit this and this. I need to consider this. So that means your R10 by 3 series will consist of 1, then 2, then 4, then 8. So like this is a again R10 series only, but with reduced numbers. How many numbers are there now? Only 1, 2, 3, 4 numbers are there. So the size is reduced. So that's why it is called a reduced series. Or sometimes it is possible to increase the number also. If you want to increase the numbers, okay. So like this. So I want between this 1 and 100, I want a series of numbers between the minimum number should be 1 and the maximum number should be 1000. I want to derive a series in that. Again, I'll use this kind of thing, R10 by 3. I'll use this designation also. So that means first I'll generate the numbers, standard numbers or preferred numbers between 1 and 1000. How I can generate numbers between 1 and 1000? But for R10, I have numbers only 0 and 10. 1 and 10. I have numbers only between 1 and 10. How I can generate the numbers between 1 to 1000? How I can generate? So if you take any series, its series factor should be same. So therefore what you have to do is, here this is the first set of up to 10 I got these numbers. Then if I want to get a second set of 20 numbers, second set of 10 numbers, this is the first set of 10 numbers. Then I want to get the second set of 10 numbers. That means second set, how I'll get? I will simply multiply all these numbers by 10. Then what I'll get is, so here I'll get 10 is already here. Then 1.25 multiply into 20. So 12, it will start from the 11th number will start from 12.5. Then 16, 20, 25, 31.5, 40, 50, 63, 80 and 100. So the last number is going to be 100. So that means I am able to generate the numbers now from 1 to 100. So then again to get the next up to 1000, then what I need to do is I have to take this second set of 10 numbers, and then again I need to multiply the second set by 10. Then what I'll get is that next number, that is here you have 20. 21st number will be 12.5 into 10, that is 125. And next number I need to multiply I'll get as 160, then 200, 250, 315, 400, 500, 630, 800, and then finally I have 1000. Like that I can generate for any amount of upper limit, any upper limit. So whether it is 10, 100 or 1000 or 5000, like that I can easily generate a series of numbers up to any desired limit. So then in that, again, if I want to reduce the size, again what I'll do is, like we follow R10 by 3. So that means I'll choose every alternative number. Not every alternative. So every third number in the series I have to select for my series. So that's what here written here. So R10 by 3 within the brackets 1, 1000. So this is the designation. What this designation, what it implies is our series starts with 1 and ends with 1000. In between, it is you have a series factor of R10, but you have to consider every third number in the series. So that is the explanation of designation of this series. Similarly, you have R20 by 4, 2000, but there is no upper limit here. So be online 1 minute. Hello. సార్ ఒకసారి క్లాస్లో ఉన్న రికార్డ్ అవుతుంది మళ్ళీ చేస్తాను నేను. Okay, so R20 by 4, 200 comma, there is no upper limit here. So since there is no upper limit, you can go for any number, but only thing is in the series you need to consider every fourth number in the series. So this is the definition of this designation. So like that you can reduce the size of the series. So that's why it is called reducing series. Similarly, series with increasing number of particular basic series. So here I have shown one example, derived series for R5 basic series. See here, it starts with 1, ended with 1000. Simply, these are the first numbers what we got from the basic series. Then these next number, this set of number, next set of number is generated just simply multiplying these elements, this set of numbers by 10. You'll get this. Then this set of numbers is multiplied by 10. You'll get this number. So like this, you can expand the series also to any number. It need not be 1000. It may be. Next, if I take this set of numbers, then if I multiply this one by 10, I'll get the upper limit as 10,000 now. I'll get 10,000 means I'll get a series. I have expanded the series to 10,000. So like that, you can expand your series for any number. But beyond this 1000 or 1000, I think there won't be any requirement for the size. Maximum limit maybe sometimes it is 1000 only. So of course it depends. So like this, you can derive the series as per all the requirement from the basic series. So there are 5 basic series are there. So those 5 basic series are constructed based on the series factor. First number you need to construct the take 1 and multiply the series factor, you will get the first number. Then multiply that number by the series factor successively, you will get the remaining numbers in the series up to 10. So lower limit is 10 1 and upper limit is 10 for all the basic series. Only in case of derived series only you have any upper limit or any lower limit also. Of course, generally we don't have negative numbers here in case of any series. Why? Because always the size can be quantified with positive numbers only. You cannot say that the diameter of the shaft is minus 30 mm like that. So you don't have any negative numbers in the any series, whether it is basic series or derived series. Always you have only positive numbers. You don't have any negative numbers because you don't have any negative sizes. So this is how we can derive the preferred number, set of preferred numbers for any required series. Okay, so then we'll I have a small problem on this, how I can get or how I can select the numbers for a given standardization. So here the question is, I'll read the question first, then we'll answer this. It is required to standardize load carrying capacities of a dumpers in a manufacturing unit. So that means here it is a standardization question. But what is the standardization here? Standard load. That means the load carrying capacity of the dumper is standardized here. The maximum and minimum capacities of such dampers are 630 newtons and 40 kilonewtons respectively. So that means for the series, standard series, you have set the what is the minimum limit and what is the maximum limit also. 630 newtons is the minimum limit and 40 kilonewtons. That means 40,000 newtons is the upper limit. The company is interested in developing 7 models. So that means within this range, 630 to 40,000 range, you want to develop 7 models only. Then what are the standard sizes for those load carrying capacities? So this is the question. So now how I can decide? So if it won't comes under if it comes under R5 series or R10 series, or for that matter R20, R40 or R80, I don't know. So then how I can decide that? I can decide that based on the number of models required within the range. See, like I mentioned in the while discussing about the basic series. For R5 series, how many models are there? There are only 5. For R10, there are 10. R20, there are 20. So like that. But here in this problem, he has given his requirement is only 7 standard models are there. So this won't comes under any one of those series. So therefore, a designer has to decide or set the required preferred numbers for this. That is the question here itself. So now to do that, first I need to calculate what is the series factor for this. So how I can calculate the series factor? So he has selected R5 as a series factor. Then, so first he assumed that 40 kilonewton as the first model capacity. Maybe here it is 630 kilonewtons, not 630 newtons. This is also kilonewtons only, 630 and 40 kilonewtons only. So therefore, the starting model, that's why he has taken the starting one as a 40 kilonewtons. Then, if it chooses R5 series, then in 7 models, how he can choose it is 40. First one is 40. Then second one is 40 into 1.58. Then third one is the number what is got it as 632 63.2 into 1.58. Then fourth model is going to be 99.856 into 1.58. So fifth, sixth, and then seventh. So like this, you can construct it. So if we want to take it from the basic series, or else he can calculate his own series factor also. How he can construct it is, he has to take the highest number. Then, in that highest number, what he has to do is, he has to take the 7th root of that 630. 7th root of 630, he can take it. So then by taking that, you will get some series factor. Then you take that series factor and you can multiply the series factor with 40. Then you get first model. First model is 40. Then you get the second model. Then the second model is multiplied by the series factor. You will get the third model. Likewise, fourth, fifth, sixth, and seventh. You can design all those things. That comes under. See here. The important thing here is the range should be 40 to 630 only. Here it is 40. Here you got it as 622. If you follow this series factor, you may get it is around close to that number, close to what you can say 630. Okay, so like this, you can standardize any number. So it need not be 7. You can standardize within the range. You can standardize any number. So as for any basic series, it need not be R5 sometimes. So people may take R10 or maybe R20. So that is again based on the requirement, because here in R5 generally what will say in R5 there are only 5 numbers, but his requirement is 7. Even though requirement is 7, still we can use R5 as a basic series, because only thing is the series factor number between the first and second is 1.58. Between these two it is again 1.58. This is between these two is also 1.58. Between these two also 1.58. Like this. If you take any two successive numbers, the ratio of highest number by the lowest number in those two always is going to be the series number value. So likewise, you can construct any set of standard or preferred numbers. Okay, so I think this is about this preferred numbers. We'll close this at this point. Then I will stop the class also because it is already 3 o'clock. So if anybody having any doubt, then you can ask your doubts. So we'll discuss your doubts, then we'll close it. Okay, I think most of you already left. No issue. If no doubt, na, if you don't have any doubts, then I'll also close it. అటెండెన్స్ ఎవరు అటెండెన్స్ ఏంట్రా? అటెండెన్స్ ఆల్రెడీ ఎప్పుడో వచ్చింది కదరా. హూ ఇస్ దిస్? వికాస్.
సార్ వికాస్ సార్ నేను.
నువ్వు ఇవ్వలేదా మా అటెండెన్స్?
పెట్టా సార్ 27 కలా పెట్టాను నేను. అది నాకు అప్పుడే వచ్చింది. అది
అప్పుడే వచ్చింది. నేను 158
అంటే రిఫ్రెష్ చేయలేదు సార్ నేను.
సరే మరి అయితే పెట్టా కదా ఏదో ఒకటి.
పెట్టా సార్.
వస్తుంది నాకు ఫీడ్బ్యాక్. కాకపోతే లేట్గా ఇచ్చాయని చెప్పి వస్తుంది.
అవును సార్ లేట్ అని వచ్చింది నాకు కూడా. అదే నాకు 27కి అప్పుడు రిఫ్రెష్ చేయాలని తెలుసు. అప్పుడు రిఫ్రెష్ చేస్తే అప్పుడు క్వశ్చన్ వచ్చింది సార్.
సరే అయితే
ఓకే సార్.
4:30 to 5:30 క్లాస్ ఉందా మళ్ళీ ఈరోజు? ఓకే. కిరణ్ సాయి పెట్టాడు మెసేజ్ 4:30 to 5:30 క్లాస్ ఉంది సార్, డౌట్స్ అని. ఓకే, సో ఇఫ్ యూ హ్యావ్ ఎనీ డౌట్ నా, సో ఆ 4:30 to 5:30 అని ఇప్పుడే డిస్కస్ చేద్దాం. లేదా యూ డూ వన్ థింగ్, యూ పుట్ ఇట్ ఇన్ ద కామెంట్ బాక్స్ ఆర్ యూ మెయిల్ మీ. క్లాస్ రూమ్ లో కామెంట్ చేయండి, దెన్ విల్ డిస్కస్ అబౌట్ దోస్ డౌట్స్. ఓకే, సో ఎనీవే ఇప్పుడు నెక్స్ట్ క్లాస్ టైం అవుతుంది కాబట్టి విల్ క్లోజ్ ఇట్. సో మీకు ఏమైనా డౌట్స్ ఉంటే యూ పుట్ ఇట్ ఇన్ ద కామెంట్ బాక్స్ ఆఫ్ యువర్ క్లాస్ రూమ్, దెన్ విల్ డిస్కస్. క్లాస్ ఉందిరా, క్లాస్ లేదంటున్నా నేను. మీ డౌట్స్ ఏమైనా ఉంటే అక్కడ పెడితే అక్కడ డిస్కస్ చేద్దాం. డౌట్స్ ఏం లేవంటే లేదంటే క్లాస్ కూడా లేదంటే జస్ట్ ఐ లాగిన్, ఐ చెక్ ఈస్ దేర్ ఎనీ డౌట్స్ రైజ్డ్ బై యూ. ఇఫ్ నో డౌట్ ఈస్ దేర్, దెన్ ఐ విల్ ఆల్సో క్లోజ్ ద క్లాస్.
Okay, sir. Thank you, sir.
Right.